So my name is Sergey. I work for a startup called Shape Security. I'm working on some web security related products. And prior to that, I worked for Qualys for 4 years. And Bei, who is not actually here because he's Chinese citizen, but he works in the United States. And if he would come here, he cannot go back to US because his visa is expired. So I'm going to represent him as well. Yeah, I'm Bei, worked for Google on Chrome-related stuff, and he joined our startup as well. And yeah, we're doing some cool things. So yeah, what is headless browser? And why somebody would need to use it? Days when people used to visit websites using curl or like wget or even netcat are pretty much over. So if you want to, I don't know, scan some website, I don't know, major websites are actually blocking curl, for example, or blocking wget just by user agent string. And also it doesn't really make sense to visit a website with curl because modern websites are highly dynamic and very JavaScript heavy, and you want to render the JavaScript and to see what's the end result before like looking at the DOM that's constructed after the JavaScript was parsed. So there are tools called headless browsers these days that hackers or, I don't know, quality assurance engineers or performance engineers are using to visit websites to basically automate things and just to have a browser experience without having a UI and just using command line tools. And so there are 3 categories of headless browsers. It can either be based on some existing headless browser, some existing browser engine like WebKit, and like Phantom.js is an example of headless browser that's based on WebKit, or Slimer.js is pretty much the same thing but based on Gecko, or Trifle.js is a new product and very immature, but it grows. It's based on Trident, which is Internet Explorer's engine. And another group or category of headless browsers is something that models a browser, and from outside it looks like a browser. Like it has all that like cookie jar, it has JavaScript engine, it probably knows how to parse CSS, but it's like homegrown. And like example of those tools is this Zombie.js or HTML unit, which is Java-based, and Zombie.js is Node.js-based framework that simulates a browser. And third category is Selenium-like things, where you actually have a real browser, Chrome or, I don't know, Firefox, and all major browsers now support this WebDriver API, which is W3C standard. It's pretty much an API to control a browser from a remote point, remote endpoint. Like Selenium is a good example of that. Like you can automate a real browser using Selenium, like write script to visit something, then click something, then get the results, or take a snapshot of the page. Anyway. So we are going to focus mainly on Phantom.js, which is based on WebKit engine, and basically it's not only WebKit. So there is a framework called Qt. It used to be owned by Nokia. Now it's owned by some other company, or it's maybe a spin-off of Nokia. I don't even know. Called Qt, and Qt has this Qt WebKit framework, which is basically a wrapper around WebKit engine, which is used in Safari and used to be used in Chrome and Opera, but like Chrome branched from WebKit, and the engine is called Blink now, and Opera also branched from that Blink. I don't even know what it's called. Anyway, yeah, we're gonna focus on Phantom.js. Phantom.js is a very popular tool. It has, I think, like 17 million downloads, like for the statistics for last month, and it doesn't include like Git clones. It's cross-platform. It works out of the box on Linux, macOS, and on Windows. And it's true headless, by which I mean it doesn't require you to simulate the graphic environment. You don't have to have a virtual frame buffer or anything like that anymore. It was one of the dependencies a couple of years back, but now Phantom.js is completely headless. So anyway, I'm going to focus on Phantom.js because it's most popular. And just a couple of words on how it works. Actually, forgive me, I enable my speaker notes. I don't want to miss important things. Let me mirror the screen. I don't know how to entertain you while I'm doing this. Displays. Yep. Agent. Yeah. Nice. So yeah, in few words, how Phantom.js actually works. So it has these two isolated JavaScript contexts. One is the actual browser's context, where on the right side is the actual Qt WebKit with its own with JavaScript context that is created for every web page that you visit using Phantom.js. And there is another JavaScript context where you actually run your commands to control Phantom.js. It's on the right side. And basically, the way it happens, your Phantom.js context actually injects JavaScript callbacks in WebKit's context, and basically, once some event is happening, you are receiving your functions from Phantom.js context are being executed on the right side, and you are getting results on the left side. Basically, that's how it works. And all these callbacks are serialized. It's like something like JSON, not something like, it's JSON, serialized into JSON. So just the main point is there are two different JavaScript contexts. So I don't know, you cannot access variables from that defined in the web page context from from the left side directly, but you can reference that variable inside your callback and get results on the left side. And basically, the simplest program that would drive Phantom.js looks like this. It's in JavaScript syntax. So basically, you create a web page, and then page.open will accept that URL, and basically, whenever that URL is loaded, the callback, that function status, blah, 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 will be executed. And in this case, what it is doing, it does, once page is opened, you evaluate returning, you evaluate document.title, and document.title will be actually executed in the web page context. And then the return value would go back to your Phantom.js context, and you'll get the title of the page. So how people usually use Phantom.js? So there are legitimate uses. Like, it's very popular, at least in US, to do performance testing of your web applications, or to do some QA, or like as slide says, like you can, like at my previous workplace at Qualys, I was working on web application vulnerability scanner, and I was actually using Phantom.js as the client of web application scanner. So to evaluate all the JavaScript that web page sends me to get the final result of what is being constructed, because using curl doesn't really make sense without understanding the JavaScript that comes with the page. And SEO used to use Phantom.js a lot because literally like 2 months back or three months back, Google's crawlers, the bots, the indexers, didn't really understand JavaScript. So people who use very highly like dynamic web applications, especially if they use something like AngularJS, they would use Phantom.js to generate the end result, basically the web page that people will see in the browser, actually. And then serve that page to the bots. serve the page that's generated by Phantom.js to the Google bots. So Google bot would index page more properly rather than parsing JavaScript that is probably being even ignored by. But now, like I think 2 or 3 months back, Google added JavaScript engine to the crawler. So now Google can evaluate JavaScript before before indexing results from the page. And yeah, for reporting or image generation, Phantom.js is probably the best tool because with one single command, you can take a snapshot of the page, you can take a snapshot of a region of a page and save it into whatever format you really want. You can implement your custom like handlers for the images. It can be anything, like PNG, GIF, or JPEG, or PDF, or whatever. So lots of people are using Phantom.js for that. And there are malicious users of Phantom.js. You can use Phantom.js for fuzzing, for example, of a web application and to cover all the possible input vectors to the actual web server. Well, yeah, you can fuzz whatever is possible on the actual web page. Or you can use it as a botnet for several things. Like it can be denial of service botnet, it can be botnet that clicks ads on web pages to drain, for example, your competitor's advertisement budget. It's pretty common. Or for content scraping, especially if website is very dynamic, it's very hard to extract the price, for example, on some e-commerce website. And especially if they are blocking curl-based clients. So yeah, a lot of people are using Phantom.js or similar things for content scraping, to extract prices, for example, from competitors' e-commerce website. For login brute force attacks, it's very common also to use Phantom.js for, to login brute force, like you are getting, or you just downloaded some database of usernames and passwords from Pastebin, and you want to try as fast as possible to see if this set of credentials work on, let's say, I don't know, some stupid dating website is compromised, but there is a high chance that the same credentials would work on the Facebook. But Facebook's login page is not that simple to work with. It's highly dynamic, and they randomize lots of arguments, or at least order of the arguments. So you cannot really send one curl request using the database of credentials, because every time request needs to look different based on the response you received from the web server. So yeah, Phantom.js is very easy, is a tool that would make your life much more easier. So yeah, web admins tend to block Phantom.js in production. And probably you want to do something to evade these blockings, and let's see what can be done. So yeah, impersonating, so yeah, if you know that website admin is blocking Phantom.js, the easiest thing to do is to pretend you are somebody else, like you are Chrome or Firefox or whatever. So it's, yeah, something like this guy. You don't really know who is visiting your website. Even if he says he's John Travolta, you don't know who it is, right? Yeah, in a couple of words, how, even if you pretend your Phantom.js instance is a Chrome browser, there potentially would be some differences because of these, the points. First, Phantom.js is using pretty old, well, there are two versions of Phantom.js. There is 1 point something, the last one is 1.9. That's the latest stable version of Phantom.js. And there's experimental Phantom 2, which is not even released yet, but you can download the sources and compile it yourself. So that 1.9, which is current stable release, is using 5-year-old WebKit engine, which is similar to Safari 5. So, like potentially, you know, what can it lead to? Any vulnerabilities that were applicable to Safari for the last 5 years probably would still work in Phantom.js, against Phantom.js. Another differences between Phantom.js and like real browsers is that Phantom is implementing several things on its own. like rendering engine, network stack is completely different from browser's network stack. It comes from Qt framework. Or like cookie jar implementation, or I don't know. I think WebGL is also different. PhantomJS doesn't natively support any kind of media hardware. Like there's no video, no audio, so trying to access, for example, PhantomJS's microphone should fail, technically. And it also exposes two JavaScript properties on window object. It's called Phantom and underscore Phantom. And underscore Phantom is not even documented, and we'll come back to this. And the main difference between PhantomJS and current modern browsers, there is no sandboxing. So everything is running within this one single process address space in PhantomJS. All the, like even if you open sort of 5 virtual tabs in your PhantomJS, everything is one single address space. So let's see if it's gonna, if it can be used somehow. So my next slides are gonna look like, I'm gonna overview some impersonating techniques of PhantomJS, how to pretend to be something different than PhantomJS, and the next slide, or slide that would contain this icon with Homer, evil Homer, would try to break that detecting techniques and or evade those detecting techniques. So let's start with the simplest one. Sorry. So we all know that browsers are supposed to identify themselves, right? So easiest thing to do is to say using user agent HTTP header that I'm not PhantomJS, I'm Chrome or I'm Firefox, whatever. So the easiest detection should be something like this in PhantomJS, right? You just test if window.navigator.user agent of the browser that visits your website contains PhantomJS, because every version of PhantomJS by default contains PhantomJS word in the user agent. So that should be enough, right? Like to detect if it's Phantom or not. Well, Phantom allows you to override, of course, any headers that going outside of the browser, headless browser. Plus, it gives you more control, so you can even override, like by executing this code, it will also change navigator object properties of the JavaScript environment. So navigator.user agent would show whatever you set through your PhantomJS script. So it's easy to evade. So spoofing user agent is not very good detection then. And what can we do? That's it. Bye, thank you. So it was a joke. I learned this word psych. It's actually like wrong. It's misspelled version of psycho or like psyched out. But yeah, eventually it's very popular word in, at least in San Francisco Bay Area. So my coworkers suggested me to use this word. So yeah, of course I'm joking. And yeah, we have this sort of winning matrix, and we're going to keep track of if some detection method is going to work or not. So user agent obviously doesn't work because PhantomJS can spoof the user agent. PhantomJS can spoof the user agent string, so PhantomJS wins in this case. Let's see what else can be done. So we know that most of the browsers would have some kind of plugins installed. So if your detection looks something like this, like if you check for navigator.plugins, which actually exposes the plugins that are installed on your browser. And if length is 0, then there's pretty high chance that this isn't a real browser, because I don't know, even like out-of-the-box Chrome would have that Pepper Flash, for example, or something else, I don't know, like PDF reader. Do we think it's gonna work? Not really. So let's say I'm the bad guy, so what I would think? I would probably guess that this website that I'm trying to do something bad with is going to check for plugins. So let's try to fake some. Apparently, it's not really possible because in all browser environments, and especially in Phantom.js, navigator object itself in JavaScript environment and plugin array property of navigator object, they are both read-only. So it's not possible to spoof them. Are we doomed? Well, not really. There is a nice trick. So if we create another navigator object in JavaScript and just and populate it using prototype chain, because actually plugin array is pretty complex structure. But if you take existing plugin array and just populate your fake one with existing constructor and create exactly the same object and then fill it up with something, or just change length to 1, as in this case, and then you create your fake navigator object, and then you just change the reference. We know that original navigator object is read-only, but the reference to the navigator object isn't read-only. So you can just point original navigator reference to your newly created navigator, and that's the trick. Well, Qt actually provides you a way to create handlers from the C++ part of the... Yeah, I didn't tell you that Qt is actually C++ based framework, so if you want to make some changes, you actually need to modify C++ code if you want to make some major changes for your Phantom.js. So yeah, from C++ you actually can register new plugins, but they are not going to be like real plugins anyway, or otherwise you need to actually implement some plugin using C++, like for example Flash, because Flash, for example, wouldn't work with Qt natively. You need to do a lot of changes. So yeah, even if you can spoof a length, for example, of plugin array, what website can do, it can just send you something to evaluate and then get some feedback from, let's say it's some Flash, which sends back an HTTP request to the website. So if that request didn't arrive within, I don't know, 5 seconds, you can assume that this website is faking. He doesn't really have, this browser is faking his Flash plugin. He doesn't really have one. So I don't know, we can probably say that website would win if somebody tries to, if website implements plugin detection and Phantom.js will try to fake one. What else can we do? What else? Oh, that other thing we can do is to look at the timing. There is one interesting property of headless browsers. It's not only Phantom, but that Slimer.js, which is based on Firefox engine, alert or prompt or confirm pop-ups that you can see in your browser, and you can create by calling alert from your JavaScript code of your website, is going to be suppressed immediately. Immediately suppresses, Phantom.js will immediately suppress the event that happened with that alert. So if it was alert, OK would be immediately clicked. And that's the default behavior of Phantom.js. So what you can do is just to create one. Well, it's of course very not user-friendly, but as last resort, you can use it. Or you can have it, I don't know, on some hidden frame, or, well, hidden frame wouldn't work, yeah. Yeah, you can just measure the time. How long would it take from the user between seeing the actual alert box and clicking something? If it's something less than 15 milliseconds, that's what we experimentally figured out, that it's not really possible to click the OK of the alert faster than 15 milliseconds. If it's faster, then it's probably some kind of automated environment visiting your website. So it turns to be a hard problem to circumvent, but let's see what can be done against it. Well, it's not really nice way of doing things, but well, in Phantom.js, you can only well, everything is, not everything, that alert box is going to be suppressed in the same thread, which is handling your, basically your JavaScript context in PhantomJS, in Qt WebKit. So, but easy way to introduce some kind of delay is just put some busy loop in the handling function of PhantomJS. So putting some just dummy cycle there would work. Of course, it will block your entire thread, but it will fake some kind of real user experience. So, but on the other hand, it's very easy to become vulnerable to denial of service attacks. If you put code like this in your PhantomJS on your PhantomJS site, a website that puts, like, I don't know, that somehow detected that maybe you are fake, and if it puts like alert box one after another on the page, it's gonna just get denial of service of your PhantomJS instance. So timed alert, probably we can say that website wins. Another observation that we made is the header order of the headers, HTTP headers. There are some major differences, actually. And those differences are coming from the fact that PhantomJS is using Qt framework's network stack to implement all these HTTP layer things. And like one of the major differences is in all major browsers except Opera, host header is the second one. Like no matter what, well, first header actually. Host header would be your first header in the header list. In case of PhantomJS, host header is the last one. So it's pretty good indication that it's not a real browser that visits your website. Or also some of the values of the headers are camel-cased, like keep alive is uppercase in PhantomJS, but it's always lowercase actually by RFC, and all the browsers are implementing it lowercase. So if you see an uppercase keep alive, it's probably something fishy going on. What can we do about it? Well, the easiest thing would be to put some kind of proxy server in front of your PhantomJS instance that would override the header order based on the actual user agent string, for example. But I don't know, putting proxy server might be not an easy solution in some situations. Like if your PhantomJS is running on some victim's machine that you have limited control, putting another server, a proxy server in this case, might be not that easy. So we could say that probably PhantomJS wins in this detection technique. Well, I mentioned this window.callPhantom and window._phantom, which is not documented. So yeah, we know that PhantomJS is going to expose the JavaScript environment that runs inside PhantomJS would have those two properties. So the easiest thing is to check if they exist. Looks pretty reliable. In fact, not. If you can just, in your web page, if you basically execute delete window.callPhantom, it will delete those properties from PhantomJS context. If you delete those properties from PhantomJS before web page is loaded, but after the DOM is initialized. It's a little complicated, but like there is an initialized event in PhantomJS which is being fired when request went out of the Phantom, but response isn't received yet or isn't parsed yet. So you have that hook there. If you basically call delete window_phantom, it's going to delete it from already created window object. So there's nothing you can do about it, pretty much. And yeah, this _phantom and call_phantom are used for, I would say, for some IPC, which is not really used much, and nobody really knows how to use that IPC. And so, yeah, not many people are using this _phantom. So just deleting them is pretty safe if you are not really using them. Or if you are using them, just rename it to something random and unpredictable, and non-enumerable. You can set that property in JavaScript to make a property of an object to be non-enumerable, and just use that random name, which only you would know, your Phantom.js script would know. So Phantom, yeah, Phantom wins again. I wasn't sure why Phantom. Yeah, Phantom. Yeah, some other things that you can look at, and we didn't because it's probably too obvious. Since JavaScript engine is too old and the WebKit itself is too old in latest stable Phantom.js, HTML5 API is not really implemented or not fully implemented. So just observing those APIs should give you a lot of ideas on whether they are spoofed or really implemented. There are other obvious properties that you can check as a website for, like, for example, window outer width or outer height, or do canvas fingerprinting, or whether navigator platform matches the actual operating system that is being declared, that your operating system fingerprinting would show you against this host if you even do that much checks. Yeah, so looking for HTML features, probably website would win because it's not really possible to spoof web audio API or, I don't know, or WebGL if it's not implemented. Yeah. Or what was that? WebRTC, for example. It'd be very hard to spoof JavaScript API that would act exactly as real browser. Well, another difference is bind. So that old WebKit engine that current stable WebKit is using, it doesn't actually have bind function. And lots of major JavaScript framework these days are relying on bind, like jQuery, for example. Actually, it's probably most popular topic on Phantom.js discussing forums or like mailing lists. People complain about that my jQuery doesn't work in this Phantom.js because there's no bind. Yeah, newer Phantom 2 actually implements bind, but Phantom 2 is not released yet, so we are living today and there's no bind. So basically, yeah, if one of the checks your website can do could be something like if function that prototype that bind is not there, then something is not right? Wrong. You can implement your own bind. And basically what bind is doing, bind is called on a function. Bind can be called on a function. It's basically a function of a function. And what it does, it takes first argument and it basically changes this of the function you are calling bind on to whatever the first argument of the bind is. And basically, it's pretty trivial to implement one. So, looks like good evading technique. So if somebody asks if I have bind, yeah, sure, I have one, but sorry. Well, it's not that easy. If you call toString on any function in JavaScript, if it's native function, you are going to see something like function and whatever function it is. In our case, it's bind. You're going to see function space bind and native code. So, but if it's a user-implemented function, you are going to actually see the function code if you call toString on that function. So, does it mean it's not possible to spoof bind? Well, it is possible if you actually spoof the toString as well, for example. And yeah, to spoof toString, it's like 3 lines like this. You actually check if the context is bind, you return something that looks like native string, like, I don't know, function bind, native code. If it's something else, then preserve the original functionality of toString. Well, toString is also a function. So what would happen if we call toString.toString? It's going to reveal this code. And we're going to figure out that toString is actually fake. Well, that means you need to do several things, actually. So in our first if, we actually spoof, we actually would check for existence of a bind. If it's there, it's there. Then we'll try to check if bind to string returns whatever we want. And our third check would be to check if actual if toString of toString function is actually not spoofed, if it's like native one. So what bad guy would do in this case? Bad guy can actually, he would need to implement several things. First, he needs to implement in toString implementation, in that fake toString implementation. First, he would need to return native string is native string if toString is called, and that second if is going to do that for you. Well, first we'll check if it's bind. We only want to fake toString for the bind, so our first if is going to check that. The second one is going to check if toString is being called. And then also, JavaScript has these ways of calling function by not actually calling the function, but applying call method or apply method. So it's going to be your function.call or your function.apply. So you want to spoof them as well. And for example, index of array. It's also probably needs to be spoofed because I actually missed that code. Because I was using index of somewhere and it needs to be spoofed, but I think I removed it or it didn't fit this slide. Anyway, it doesn't really matter. PhantomJS is going to win if bind is not implemented and you want to actually fake it, spoof it. Well, another observation is that putting aside PhantomJS 1.9, which is current stable, PhantomJS 2 is actually very, very ECMAScript 5 compliant. And so there is a set of tests called Test 262. It's developed by ECMAScript proposal writers community, and whenever new feature is added to ECMAScript specification, some tests are also covering that feature. Those tests might not pass forever, like because somebody decide, well, because later browser developers decide that it doesn't make sense to implement this feature, but test is not going to go out from the test suite. It's just going to fail all the time. And Phantom 2 is actually behaving exactly the same as Safari 7. So whenever PhantomJS 2 is going to be released, it's going to be very non-reliable to look at like missing features of JavaScript. Like bind is going to be there, and that bind is going to look exactly the same as bind in Safari 7, for example. So yeah, it's not, whatever we discussed earlier about JavaScript engine differences, it's not going to work with PhantomJS 2. But let's see if we can look at something else. Well, there is, yeah, we know that looking at call phantom is not is unreliable, or looking at that window that underscore phantom is unreliable. But we can make our visitor's browser to throw a stack trace, and we can observe that stack trace later. And here is like examples from PhantomJS and from Slimer.js, which is Firefox-based, Gecko engine-based headless browser. Like stack trace for exactly the same JavaScript error. I think it was type error. We don't see type error anywhere, but I know that it was type error, type of an error. Stack traces are completely different, but there is something common. Both stack traces contain PhantomJS somewhere. So what can be done? You can just simply look for PhantomJS, right, in the stack trace. If stack trace contains Phantom.js, then probably this is Phantom.js, or somebody who wants to look like Phantom.js. Actually, Slimer.js added that Phantom.js to be Phantom.js compliant because Slimer.js implements exactly the same API that Phantom.js provides. It just uses different backend engine. And actually, the Trifle.js, which is IE version of Headless browser, it also has Phantom.js keyword in the stack trace. So if you simply throw in your code, somewhere throw an exception like this, like null, accessing null 0th element is going to throw an exception. It's going to throw type error exception. And then you just catch it and just search for Phantom.js. If it's there, then it's probably Phantom.js, right? And yeah, very good thing in this particular example, that it's impossible to spoof the error object if it's thrown by JavaScript engine directly. You can spoof any, like if you actually call throw error, that error can be anything, and it can be spoofed. But if in this case, error is going to be thrown by by JavaScript engine itself. So it pretty much guarantees that the error object is not touched by anybody, and that stack property of that error is also not touched. So it's pretty reliable to look at the stack trace. Well, what if we try to, where's my, oh, okay. So I tried to see how easy would it be to modify the C++ code of Phantom.js to change the appearance of the stack trace. It turned out it's pretty easy. So I tried to, for example, replace, just a second. Sorry. Actually, in that first block, 1, 2, 3, 4, 5, 6. Sixth line, that QString, Phantom.js, blah, 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 webpage.evaluate. If you comment it out, it was deleted, but I don't know, something happened. If you comment out that line, it pretty much hides Phantom.js traces anywhere in the stack trace. So your stack, so the stack trace thrown by the Phantom.js would look like this, this text in the second box. It doesn't have any references to Phantom.js, but still it doesn't look like real browser stack trace. Plus, pay attention to this last line where actually Phantom.js exposes full path to the script that was used to visit the web page, and we'll come back to this later. It's pretty non-secure behavior by Phantom.js. So instead of just deleting that code that I showed, that QString, blah, 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 we tried to spoof Chrome's stack trace in Phantom.js. So we know that Chrome contains this object that injected script that underscore evaluate on. So I just replaced Phantom.js with that text. But still, stack trace is like on the top is Phantom.js stack trace, and on the bottom box, in the bottom box is the stack trace for exactly the same error thrown by Chrome, and they're still pretty different. So if you do some kind of pattern matching, and it's not going to be very long, you can actually detect or detect the family, at least, of the browser that's visiting your website. And it's going to be completely transparent to the end user because you are going to catch that exception and you are not going to propagate that further. So it's pretty good detection. So looking at stack trace, website is going to win probably, unless you completely rewrite the WebKit engine or JavaScript engine of the Phantom.js, that basically the Qt WebKit, which comes with Phantom.js, and like make stack trace exactly the same as Safari, but it's lots of work, and probably nobody's going to do that. We'll just switch to some other website. So the result of our scoreboard is so far like equal. And I cannot really recommend which technique can be like more reliable than other than that looking at stack trace is pretty good thing to do, but we'll come back to this. So anyway, so you are a website admin, you know this guy that visits your website, he's using Phantom.js, and you probably don't want Phantom.js to be there, and you just caught him, but now what can you do with it? Lots of things can be done to Phantom.js that visits your website and you don't really want him there. So there are several observations that Phantom.js is usually running as the same user as your console. So nobody really like downgrades the privilege level when he runs Phantom.js. It's like if you are root, you are probably just typing Phantom.js and the script name, and Phantom.js process is going to run as a root. And there's no sandboxing. And it executes JavaScript from who knows whose website. And Phantom.js also, since it's based on Qt WebKit, and Qt WebKit is using, well, it tries to catch up, but if you search Qt for like security vulnerabilities, you'll find that like libpng is outdated, or libxml, or like a couple of months back, libjpeg was outdated. They are trying to apply patches, but of course it's going to take some time before between 0 day of some library that Qt is using and the actual patch. And yeah, what can it lead to? Well, either abusing the Phantom.js process itself, or maybe like even operating system. What else can be done? So if we try to a little bit just extend the function that I showed, the stack trace detection, if we try to extend it and do something, well, relatively harmless to Phantom.js visitor, it's probably going to work. So, so there's one important thing. To have Phantom.js appear somewhere in your stack trace, you actually need to trick Phantom.js script to evaluate the code, your code, that is going to throw that exception. So to do that, you probably want to, I don't know, overload some DOM API that's probably going to be used by Phantom.js, and like document.querySelectorAll or document.getElementById is most likely is going to be called by Phantom.js. So if you try to overload it and overload it, basically wrap the original querySelectorAll, which we call on the last line. If you wrap it with the detection that we discussed earlier by throwing an exception and blah, 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 and searching for Phantom.js string, and actually return something stupid if you actually detected Phantom.js, and do not return anything stupid if you didn't detect Phantom.js, it's really going to make that guy's life hard, because he's not going to figure out, or it will take him a while to figure out what's happening, why querySelectorAll returns parent element, or what am I returning? Yeah, I'm returning, yeah, HTML, yeah, anything that matches HTML. But in fact, if somebody tried to search divs and he's running Phantom.js, he's going to get list of HTML elements on the page, which is normally only one. But yeah, he's not going to figure out what's happening. And especially if you try to like obfuscate that code, it's going to make his life even harder. So it's a pretty good thing to do, and maybe it's good practice if you don't really expect any Phantom.js visitors. So to wrap up, the idea is that if you don't really need a full-blown browser engine, don't use it. By which I mean that if like curl or netcat is going to serve your needs, just use curl or netcat and change user agent if curl user agent is blocked. Oh, there's other important thing. You can run Phantom.js with web security equals false, and lots of frameworks are actually requiring you to use web security false, which is basically disabling same origin policy. It is easy way to bypass same origin policy for somebody who's using Phantom.js to report something to some third party. Like if you are doing some performance testing and the same code is reporting results to some other web server. Instead of configuring cross-origin resource sharing, they're basically just recommending you to disable same origin policy. I'm actually missing that slide, but it's actually very easy to steal files from local file system if web security equals false. Because Phantom.js is going to let you access local file system. If you know exact file path, it's going to even let you have a file scheme in the URL. And you can read any file from file system and send it somewhere, wherever you want. So yeah, never disable that. Try not to visit arbitrary pages. Like if you are targeting something, go there with browser, inspect it first, see if there's no obvious traps for headless browsers, and then point your Phantom.js. Or if you are, I don't know, scanning Alexa top 1 million websites, I don't know, probably run it in virtual machine or something. Yeah, if security is really a requirement, use something with higher security standards, like use real Chrome, for example, and control it with Selenium to automate whatever you are doing with Phantom.js. And just recommendations for web admins. If you don't really care if headless browser is visiting your website, do not really try to detect it, because sometimes it's really hard. And make sure you want to unveil the actual browser engine that visits your website. Try to sniff for headless browsers, because yeah, I didn't really talk about those, but it's pretty popular technique to sniff to overload, for example, navigator.userAgent with some JavaScript code that checks if somebody is actually reading your user agent, just disconnect. It's pretty common JavaScript code that people put in their Phantom.js scripts because they don't want to be, they just don't want trouble. Combine several techniques that we described. Like, yeah, look at stack trace, but don't only look at stack trace. Look at, for example, plugin array, because still there is a chance that this guy is very smart and he rewrote the entire WebKit engine to make stack trace look as the real one. And you can actually, so we gathered all these examples in a form of really working JavaScript files in this repo that you can visit. And basically, the way that framework works, you provide two files. One file, first file contains the detection technique, and second file contains the actual evading techniques. And you can play with it. I'll actually show you how it looks like. Oops. Just a second. Yeah, so it's something like this. I don't know if you can see. Okay. Oh, it doesn't fit on one line. So basically it's, oh, no, it's not this one. It's this one. You just type HS loader, and then, it's not a good example. Nope. Here. So yeah, we have these files, like first character of the file indicates the attack type. And like for 5, for example, you have the detector code and bind detection code and bind detection evading code. So you simply type something like HS loader 5 dot detect missing function bind, and then space 5 simple function bind.js. And it's gonna well, this is for 2. I don't even know what 2 is, but end result is going to be something like who won. In this case, Phantom.js is not detected, although we used Phantom.js. So for attack 2, Phantom.js won. Just a second. Another example, actually, I don't know why those slides are missing, but if you go to Google and search for WebKit vulnerabilities and just pick the first one that actually, pick first page that has actual proof of concept and run it against Phantom.js, you'll see some interesting results. I don't want to run it right now, but I should have something here. I ran it before the actual talk started. This exploit is by Google security team. It exploits JavaScript's array.join implementation of the strings. So if you have huge array of strings and call join, it will crash and it will have predictable mem move fail at predictable locations. So you can imagine what this can potentially lead you to. So yeah, either don't use Phantom if you are really scared of things like this, or I don't even know, or try to patch the WebKit engine. Because this vulnerability was valid in the beginning of this year. It is patched in all major browsers, but it's not patched even for the latest Phantom 2. So I don't even know, like probably use Selenium. Sure. And where is my cursor? Here. And yeah, that's pretty much it. There's a list of useful resources that you can use. And thank you very much. And yeah, questions, of course. If any questions, I'll be happy to answer.
Any reliable method of detecting Selenium?
It depends on what's the purpose of detection. No, there is no reliable method of detecting Selenium, but there is reliable things, well, relatively reliable methods to detect if Selenium, for example, modifies the DOM. Like Selenium-driven code adds new DOM elements, for example. But you cannot do anything if Selenium just, I don't know, is used just to dump the DOM somewhere. Like if Selenium doesn't modify the DOM, yeah, no, I don't know what to do. Other questions? Actually, on Selenium, it's very good. Have you had any experience on detecting Selenium, or you're just wondering? Try to detect or try to visit a website?
Try to detect it and really couldn't find a single way of doing it.
Yeah, Selenium doesn't really expose anything because it just controls a real browser, but well, it's a good thing to think about. No, there's no reliable ways, actually. All right. Thank you then.